Let's explore algebraic limits with regards to absolute values, which seem pretty simple, but you'll see that they can be rather interesting. Algebraic limits with regard to absolute value, okay? So consider, first we're going to kind of familiarize ourselves with absolute values and understand why they can be tricky sometimes. So we'll take an example here. Let's consider the absolute value of x plus 3, okay? We want to understand this function better. And before we do that, let's point out some basic ideas with just numerical absolute values, no variables. So if I want the absolute value of 5, of course that's 5. And you notice that the output of the absolute value is the same thing inside the absolute value. An absolute value will output the same value as long as what you input is positive or equal to 0, right? So if I have the absolute value of 1.4, since 1.4 is positive or equal to 0, it's going to also output 1.4. Simple enough. The interesting part is what happens when you input a negative. So if I input negative 5 to the absolute value, what it does is it outputs the opposite of what's inside. So it outputs the opposite, in other words, negative 5, okay? Which of course is a complex way of saying positive 5. So how does the absolute value function work? If what's inside is negative, it's going to output the opposite of that negative value. If what's inside is positive or 0, it will output that value itself, okay? So let's keep that in mind as we work to understand the absolute value of x plus 3. So how can we think of the absolute value of x plus 3? Well, the absolute value of x plus 3 is going to output one of two things. It's going to either output x plus 3 itself, right? Or it's going to output the opposite of x plus 3, which looks like that. Now, when does it output each of those? Well, when does an absolute value output the same thing that's inside? Well, it does that if what's inside, in other words, if x plus 3 is greater than or equal to 0, okay? When does it output the opposite of what's inside? Well, it does that if what's inside, x plus 3, is negative or less than 0. Okay? Now, this is what we call a piecewise defined function. The output is one thing in one scenario, and the output is something else in a different scenario. Typically, this statement here, the if statement, is in terms of just x. So what we will do is get x by itself in each of these statements, and we do that simply by subtracting 3. So I'm gonna cross these out just to leave remnants behind so we can see what we did. And I'm going to replace this by saying if, and if I subtract 3 from both sides, x will be greater than or equal to negative 3. And here, if I subtract 3, it would be x is less than negative 3. And so the absolute value of x plus 3 is either going to output what's inside the absolute value or the opposite of what's inside the absolute value based on the value of x that you want to substitute into the function, okay? So keep that in mind as we work through a limit example of how this can be valuable for us. All right, so now let's consider a limit. Let's look at the limit. We'll do a slightly different absolute value so you can see it in another scenario as well. Let's look at the limit as x approaches negative 5 of the fraction, how about x plus 5 over the absolute value of 2x plus 10, okay? Consider that limit. Now, the key is you can't use direct substitution because if you plug -5 in for x, your denominator is 0. The other thing to recognize is if you look at numbers slightly left of -5, what's inside will be negative. 2x plus 10 would be negative. For example, if you plug in -5.1, which is slightly to the left of -5, 2 times -5.1 is -10.2. -10.2 plus 10 is a negative number, okay? If you plug in a number slightly to the right of -5, like -4.9, 2 times -4.9 is -9.8, plus 10 is positive. So -5 is that threshold where 2x plus 10 shifts from negative to positive. So what we have to do in this case is we have to look at both one-sided limits to evaluate this. So let's consider the limit as x approaches -5 from the left of this fraction. Now, whenever x is, again, to the left of -5, we already said 2x plus 10 is a negative value. Everywhere to the left of -5, 2x plus 10 is a negative value. And we discussed that if what's inside the absolute value is negative, then it's going to output, the absolute value is going to output the opposite of what's inside. So in other words, it's going to output negative times the quantity 2x plus 10. Okay? Now there's no absolute value. Let's see if we can algebraically simplify this. So this will turn into the limit. We can pull a 2 out on bottom. So this turns into x plus 5 over -2. When you pull the 2 out, it turns into x plus 5. And now these cancel. And so we've got, let me make sure you can see what I'm writing. I don't want to go off the screen here. Okay, we're good. We have the limit as x approaches -5 from the left of 1 over -2, which is -1/2. And since this is a constant, since we're taking a limit of a constant, the answer is just the constant. It's totally independent of the x value. So as we approach -5 from the left, this function approaches -1/2. Now let's do the limit as x approaches -5 from the right, which should be pretty simple now. The limit as x approaches -5 from the right of x plus 5 over the absolute value of 2x plus 10. And again, when we're to the right of -5, remember -4.9 for x, anything to the right of -5 makes 2x plus 10 positive. And when what's inside an absolute value is positive, it just outputs what's inside the absolute value, which is 2x plus 10. Okay? So we don't need the absolute value if we're looking to the right side of -5. And similarly, we can factor a 2 out on the bottom. Cancel the x plus 5s, and we end up with the limit as x approaches -5 from the right, which happens to be irrelevant, of +1 over +2. And again, that's constant. So the answer for the right-sided limit is +1/2. And so what we see then, if we want to consider the two-sided limit at -5, we see that the limit, the two-sided limit, as x approaches -5 of x plus 5 over the absolute value of 2x plus 10 does not exist because the two one-sided limits are different. Okay? And so when you're dealing with absolute values and you're taking a limit as you're approaching a value where the absolute value goes from negative to positive, you need to consider the limit from each side because the output of the absolute value changes. Now, if x were approaching -6, for example, excuse me, -6, everywhere near -6 is going to make 2x plus 10 negative. So we would simplify it in this fashion here. But furthermore, we wouldn't need to do that because we could just plug -6 in because that would make our denominator 0. Okay, so some interesting things that are going on with absolute values, but I hope this technique makes sense. It can be a little work to get a handle on absolute values and how to think of what they output in different scenarios.